What's good? Welcome back to another episode of How to Algebra. Today we're diving deeper into the world of series, focusing on arithmetic series and sigma notation. Sigma notation is like shorthand for summing up terms in a series. It may look complex, but I promise it's a breeze. We'll unravel the mysteries behind sigma notation and master the art of calculating arithmetic series with ease. So get ready to harness the power of sigma and conquer arithmetic series like a math ninja. Let's get it. All right, so continuing the conversation about series, arithmetic series, it's very natural to bring up the topic of sigma, the notation for sigma. So the sigma notation is, well, it's represented by the capital letter, Greek letter, sigma. It kind of looks like a odd-shaped E, but it's a Greek letter, capital letter, sigma. And we use it in math to represent a series, meaning, because if you think of what a series is, right? A series is just a sequence of numbers, and every term is being added. So something is being added to the next thing, which is being added to the next thing, which is being added to the next thing, right? So there's an order that's happening. And to represent a series, we use sigma. So once you understand how to read it and understand what you're looking for, it's not a hard concept at all. So the sigma has the indexes above and below it. So the sigma symbol, which you see here. So this is saying the sum, right? The sum of, that's how it's read. So the sum of two n plus 5 for n equals 1 all the way to n equals 4. So from n equals 1 to n equals 4, we want the sum of 2n plus 5, where you take 1, 2, 3, and 4, right? So this is where you start, and this is where you end. And then you utilize every n value in between the start and the finish, or the top and the bottom, or however you want to look at it. But you always start at the bottom number, and then you go to the top number. Now, some textbooks or other teachers may use another letter other than n. So we'll be using n, but you could use I, J, I've even seen K. Whatever variable is utilized, right? So for the purpose of these videos, we're going to be using n. So when n is 1, all the way to n is 4, of 2n plus 5, right? The sum of all those added together. So this, in the end, will equal a number, right? Some value. It'll be some value. All right, so the idea is that we expand, right? We expand. So this is the same example. So the first term, n equals 1. So 2 times 1 plus 5. Right. So that's the first term. I'll use a different color to keep it separate. We're going to add it to 2 times 2 plus 5, right? Because that's the next n value. Two times 3 plus 5. And then finally 2 times 4 plus 5. All right, so this is the sum. You might hear it referred to as a summation, right? As summation or sum. Either way, sigma is the sum of, right? Because it's adding up a whole bunch of things, and it's adding up these things. So 2 times 1 is 2 plus 5 is 7. 2 times 2 is 4 plus 5 is 9. 2 times 3 is 6 plus 5 is 11. 2 times 4 is 8 plus 5 is 13. All right, when you add these together, you get, see, 9 and 11 is 20, 23, or 20, 23, 33, 40. Right, 20 and 20. Okay. So the sum of 2n plus 5 from 1 to 4 is 40. Pretty simple. All right, so let's try another example. So this is the sum of 2n minus 3 from 1 to 6. So we're adding up all the values from 1 to 6. All right, 2 times 1 minus 3 plus 2 times 2 minus 3 All right, so 2n minus 3 from 1 to 6. 2 minus 3 is negative 1. 4 minus 3 is 1. 6 minus 3 is 3. 8 minus 3 is 5. 10 minus 3 is 7. 12 minus 3 is 9. All right. Basic addition, right? Negative 1 plus 1, those cancel. So then 10, 19, 24. So 2n minus 3 from 1 to 6 evaluated would be 24. All right, write the terms in the series, then find the indicated sum. All right, that's basically what we've been doing. So I'm not going to change colors this time. I feel like we have a good handle on it. So 3n minus 2. Okay, so here are the terms. Expand it out. And now we'll do some simplification here. So 3 minus 2 is 1. 6 minus 2, 4. 9 minus 2, 7. 12 minus 2 is 10. 15. Yo. That was weird. 15 minus 2, 13. 18 minus 2, 16. 21 minus 2, 3 times 8 is 24. Minus 2 is 22. Okay, I did that quickly. Hopefully there's no mistakes. Let's double check real quick. 9, 12, 15, 18, 21, 24. All right. Okay. So then we just add these up. You could use a calculator if you want. So 20, 44, 50, 60, 70, 77, 90, 4, 94. Hopefully that's what you got. 94. Okay, so here we want to write the sum. Okay, so here this is kind of going in reverse, right? So here we have a series and we want the first 10, but we want to use sigma notation. So let's see if we can figure this out. So sigma, and I want the first 10. So let's see if we can figure out what the pattern is. So it's decreasing by 5. So maybe if we did 80, right, starting with the first one, and we're subtracting 5 in, right? Because, so let's kind of test it out. So at 1, at 1, that would put us at 75. So that's not cool at all. So let's adjust. I did 85. So at n equals 1, technically, so there's multiple ways of doing this. Just know that, right? So technically, I'll show you 2 different ways, right? I'll show you 2 different ways. So I'm going to go back to the original equation that I had and then see if maybe you can figure this out. So at n equals 1, we're going to get 80 minus 5, or 85 minus 5, which is 80. So that's good. Then when n equals 2, it's going to be 85 minus 10, which is 75. And then at n equals 3, we should get 70, right? Because 85 minus 15 is 70, so on and so forth. So this would work. And we want the first 10 problems, or first 10 terms. So from n equals 1 to 10. All right. Another way of doing this, can you think of how could we use this problem? All right, hopefully you see it by now. If we let n equals 0, right? N equals 0. If n equals 0, then the first term would be 80. At n equals 1, the second term would be 80 minus 5, which would be 75. And then the pattern would keep going. So we want the first 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 0 to 9. So either one of these would actually work, right? And again, you could start at 1, you could start at 0, you could start at whatever number you want, actually. So yeah, I think this is good. So recapping, we have the Greek letter sigma, and it basically means the sum of. So you're going to create a series, right? Because that's what a series is. It's terms being added in order. And whatever, we could say the argument or the formula or equation, whatever you're given, you always use the indexes. So you start at the bottom number below the sigma, and you go up to the top number. And that's pretty much it. All right, so good luck. Hopefully this video helps you out. Catch you in the next video.